Tonight's video is going to be on pages 29, 33, and 34. This is going to be a great set of 3 examples that will really connect the dots of what we've been learning these past couple of nights. The objective of these 3 questions is to be able to identify and decide if you're being given a restriction on the domain, a restriction on the range, or if there is not an actual given restriction, and then you would just need to consider what does the real world say about what you're dealing with in terms of a real world restriction. Let's read this first one. And some of us may have actually already tried this if we've been doing our class practice, so this will be a great way to check our answers together. It says, Kenny runs his own plumbing company. He has planned a job for a customer and has estimated that it will take at most 5 hours to complete. He charges an initial fee of $140 plus $70 per hour for labor. Let H represent the number of hours, so I'm going to underline that because it's defining my variables, and C be the total cost. Then I see that it gave me a model, so I will highlight that model. C of H equals 140 plus 70H. And now I'm asked to divide my variables. Well, because I did a nice job here of underlining as I read, I see that H is number of hours, and C of H will be cost. Now for my domain, I know domain is all about X and range is about Y, but we've graduated to also adding a label here above. So my input value is the hours. So I know my domain will all be about number of hours. And range will be about total cost. Move that over so it's not too much in the way. All right. We are now going to reread. So for those of us who maybe just joined Google Classroom, or this is our first video that we're watching, I'm really big about putting some nice notes here in the margin to help you remember what we're about to do. So read, and look for a given restriction on hours or total cost. And we're looking for that because that's what we're dealing with. We've got hours and we've got money. So let's reread. And if I read, I see Kenny, he owns this company, he's planned a job. And then I see it says it's estimated that it will take at most 5 hours to complete. So I'm going to circle that. Then I'm going to ask myself, is this a restriction on hours or cost? Well, hours. So if I've done my labels, I can actually just draw an arrow right down to hours and realize, with the help of this visual here, that this is going to be a restriction on the domain. So if I have up to 5 hours, well, not me, Kenny has up to 5 hours to complete this job, it's going to be 0 to 5 hours. We've had some class discussions for a couple people who tried this on their own at first, and don't write what I'm about to write in blue. A couple people did this at first, and I could totally understand why. And then we had a conversation about how if you write this, you're saying for hours is 140 to 70 hours, which doesn't really make sense, and that's not what the problem told us. And then we had a conversation about how a lot of people, maybe when they were reading, they saw this and they're like, oh, that's my domain. So we really have to be careful that we read carefully for information. And something that could help us not make mistakes like that are little things like above domain, put a label, above range, put a label, and then when you find a restriction, circle it, and then draw an arrow to where it goes. So we have successfully reread and looked for the given restriction on hours or cost, and we found one on hours. So the fact that it was hours means we were given a restriction for the domain. So at the top, can you make it super big, given restriction on domain. So if I'm given a restriction on the domain, my next step is to realize this is my smallest x value and this is my largest x value. So next, we are going to sub in the values from the domain into the equation to calculate values for the range. And again, by writing this on the side, you're creating a conversation you can refer to later in your notes. So we are going to sub in the values from the domain into the equation to calculate values for the range. We are going to use this equation. So I look, my first x value that I'm going to evaluate is 0. So we're going to say C of 0 equals, and I'm going to use the model I highlighted as a guide. C of 0 equals 140 plus 70 times 0. Draw a line. That's going to be 140 plus 70 times 0 is 0. So then we have 140 plus 0 is 140. So this means he hasn't actually done any work yet. And as soon as you walk in the door, or not you, as soon as he, the plumber, Kenny, walks in the door, your bill is $140 as an initial fee or initial cost. And in class, we had a conversation about how some thought that was really a lot of money. But imagine if you've called a plumber and it's like 1 in the morning, and yes, he's on call, but it's 1 in the morning and pipes are frozen and water's everywhere. That plumber has to get up at super early, crazy hours and get to your house. If you were that plumber, you would want to get paid for that. So keep that in mind when people say about an initial fee or that cost before they've done anything, they are looking to make a living as well. So we've got 140 when we plugged in 0. Now we're going to take 5 next and plug in 5. So C of 5 equals 140 plus 70 times 5. Draw a line. We've got 140 plus 70 times 5 is 350. If you haven't taken out your calculators yet, press pause so that you can go get your calculator and do 70 times 5. And I do 140 plus 350 and I get 490. These are the values that I need to write my range. So it's going to be C of H is between 140 and 490. To summarize, we plugged in our smallest x to find the smallest y value, and then we plugged in our largest x to find the largest y value. Let's talk about graphing. I'm going to use interval notation to write the domain and range we just found. So my domain was 0 to 5, and my range was 140 to 490. We could, in theory, set up a t-chart like a table. We've got x, we've got y, and decide some values for x and decide values for y. Well, to decide values for y, we have to do some math, right? Like let's say I chose 10 and 20. I would need to plug in 10 and 20 into this equation to get out some y values. But we've actually already done that work. We had an x value of 0, and when we plugged in 0, we got out 140. And we had an x value of 5. And when the x value was 5, the output we calculated was 490. So use domain and range values to build ordered pairs. This will be 0, 140 and 5, 490. Let's get to the graphing. So first let's get labels. I go remind myself that x is hours, y is cost. So I put hours and cost. I look at the ordered pairs I am going to graph. First let's look at the x values only. That's 0 to 5, so I put 0. Now I could go 1, 2, 3, 4, 5. There's really nothing wrong with that, but I notice I'm kind of only using half of this graph. So maybe I skip a line and I go 1, 2, 3, 4, 5. That's more spread out. That's nice. That's the great part about using pencil. Hint, hint to anybody using pen. Use pencil because then if you don't like your scale, you can erase it and go back. Now let's look for the y values. 140 to 490. So that's approximately, we're going to be starting at 0. That's like 0 to 500 on the y-axis. So if I'm at 0 and I'm trying to get to 500, to count, once again, my first thought 0 to 500, at least for me, was, ooh, 100, 200, 300, 400, 500. Notice how much of the scale you haven't used, though. So maybe we go 100, 200, 300, 400, 500. So this is nicer. It's not all scrunched at the bottom. I mean, I still technically have a little bit that's not used, but I'm content with this. If you want to try something different, that's fine too. Erase and count by something else. Remember, scale is an art, not a science. There's definitely more than one right answer. My first ordered pair, 0, it's going to be 0, 140. If you do want to write that, you can. So 0 means in the x, I don't go left or right at all. I'm going to go up 100. 150 is halfway, so 140 is going to be between 100 and 150. And then I've got 5, 490. So there's 5. And if I look, 500 is here. 490 is going to be right underneath. Our line is going to be a line segment and not a line because it says he works up to the 5 hours. He is not working past 5 hours. And our graph is complete. So this wraps up our example of giving a restriction on the domain. So this is the first of 3. Let's go get to page 33, which is this car that's got a gas tank that can hold 16 gallons. And we'll see which type this ends up being. So a car has a 16-gallon gas tank. On a long highway trip, gas is used at a rate of about 2 gallons per hour. The gallons of gas G in the car's tank can be modeled by this equation. G of t equals 16 minus 2t, where t is the time in hours. I'm not sure if anybody noticed how I just read all the way through and didn't do anything. I was trying to imitate what some of us do when we just read, and we don't slow down and use our reading for information skills. So now let's see what the difference is when we read a little slower and when there's something we can do, we do it. A car has a 16-gallon gas tank. On a long highway trip, gas is used at a rate of about 2 gallons per hour. The gallons of gas G in the car's tank can be modeled by this equation, where T is the time in hours. Notice the difference. By the time I finished reading this time, both my variables had been given to me, so I underlined them, and my model is highlighted so it stands out. We're ready to define our variables. T is time in hours. G is gallons of gas. Here I'm asked actually a follow-up question. First, how long can they drive until they run out of gas? Well, think about what it means when you run out of gas. How much gas is left in the gas tank if you have run out? I'm hoping we're all saying 0 gallons. So that's what we're asking. How long until you have no gas? Well, interesting question. To help us answer that, I'm going to rewrite the equation we were given. G of t equals 16 minus 2t. My question to you is 0 gallons a value for t or G of t? Well, if I plug in 0 for t, I'm saying 0 hours. That's not what I'm asked. I'm saying how long until they run out of gas, 0 gallons. Because I've defined my variables, I see that 0 gallons will be a value for G. Here, my output notation is actually in function notation, so this entire piece becomes 0 equals 16 minus 2t. And now I'm ready to draw a line down my equal sign and solve. So we have plugged in 0 for the output, and we are going to solve for t. We're going to solve for the time. Let's do that. So first, I see I have a positive 16. We're solving a two-step equation here. I'm going to isolate the t term where I see the variable. So that becomes negative 16 equals negative 2t divided by negative 2. And we get t equals 8. T equals 8 is the mathematical answer, but I want to make sure I know what the real world answer is. I was asked how long, so we were looking for time. In fact, we found t, and I can even come up here and see, hey look, t is time, hours. So it's going to take 8 hours of driving before you run out of gas. That's a pretty decent amount of time. Now let's see what we can say about domain and range. Before we do anything else, remember we have this strategy of writing a word above it. So above domain, we're going to write hours because that's what my inputs are all about. T is time and hours. And then what are we going to write above range? Well, I look, my outputs, it's all about gallons, which makes sense. It's once you know how many hours you've been driving, you can figure out how many gallons of gas you have left. I come up and I look, and I ask myself this question from the other page. Reread and look for a given restriction on ... For us, we are going to reread and look to see if we're given a restriction on hours or gallons of gas. So I come up here, and I'm going to give you a second to reread. Are you given a restriction on hours or gallons of gas? I'm hoping that it stands out to everyone what it said here about this car only having a gas tank that can hold 16 gallons. It makes sense that we'd have a limit on gas, or gallons of gas, because gas tanks don't have an infinite amount of storage, right? So we have a restriction on gallons. So I'm going to draw my arrow to where I see gallons, which is not the domain. It's the range. So this is an example of being given a restriction on the range. So up to 16 would look like, we've got G of T between 0 gallons of gas and 16 gallons of gas. So this is very similar but also very different from our last question, because the plumber question, you were given a restriction on the domain. Here, we are being given a restriction on the range. So let's actually put that at the top. Given a restriction on the range. Nice and big so that when you're flipping through your workbooks, it'll stand out. Given a restriction on the range. So now, need to sub in Y values to calculate X values. Before we plugged in X to find Y, now we're going to plug in Y to find X. So I look at the values I need to plug in. I'm looking to sub in 0 and 16. But if I pay attention, have we already plugged in 0 somewhere? I'm going to pause for a second and let you look at this whole page and figure out where on this whole page have you already done that. Check out part B. You've already figured out how long it'll take you to have 0 gallons of gas. Bam, 8 hours. Let's prove it to ourselves though. I'm actually going to kind of like hide that part of the video from you. Let's pretend like that hadn't been the question. Off to the side I could say, okay, I have to let Y equal 0. So I would calculate 0 equals the model G of T equals 16 minus 2T. And I would solve, plugging in my smallest Y to find my X value. And we would get 8. Now I held back from saying that we plugged in our smallest Y to find smallest X, because in this situation, it's actually not the case. Because if you think about it, you can drive up to 8 hours. So this actually finds us the larger value. You can drive up to that much time. When we do our graph, it's going to make more sense. Let's explore what happens when we plug in 16. So I'm going to substitute 16 in for Y, and I've got 16 equals 16 minus 2T. I subtract 16 from both sides. Ooh, check that out. I get 0 equals negative 2T. When I divide by negative 2, I get T equals 0. Interesting. Does that make sense? Well, let's step back and think about it, right? If you have 0 gallons of gas left in the gas tank, it means you have driven T equals 8. You have driven 8 hours. On the flip side, if you have 16 gallons, remember this is 16 gallons of gas, right? If you have 16 gallons of gas in the tank and the gas tank holds 16 gallons, have you driven anywhere? No, you haven't even started your trip. You've been driving for literally 0 hours. You're still parked at the gas station. So to build our domain, that's going to be between 0 and 8 hours. Up till now, we've had a practice of using the domain and range to kind of build ordered pairs, and we still can do that, but with this one we have to be a little more careful because it's not as direct as the other ones have been. So my domain is 0 to 8 hours, gas is 0 to 16. Unlike the other ones where I was able to say smallest x with smallest y and largest x with largest y, that's not going to work because if you really think about what that means, domain, right, domain is all about hours and range is about gallons. It doesn't make sense. If you've not driven anywhere, you don't have an empty gas tank. You haven't driven anywhere. So my recommendation is, now that we're getting stronger with our calculations, I would pull my ordered pairs starting now, especially if you're given the range and you're going backwards to find the domain. T equals 8 gets me the ordered pair 8, comma, 0. When y was 0, we found 8. This was my x value, this was my y value. Here, t is 0, and then my y value was 16. And you'll see what looks different about this. You'll see in a second why we can't just say 0, 0, 8, 16. So let's graph it so we can see why this is. Let's put our labels. So this is going to be time in hours. This is gallons of gas. For my domain, we're going 0 to 8. So 0, I'm just going to go with not putting anything down. 1, 2, 3, 4, 5, 6. So I can't skip one. So it's going to be 1, 2, 3, 4, 5. Every tick mark is going to be used. 6, 7, 8, 9, 10. And then for my range, I have to get to 16. Here's my range. Let's see. 1, 2, 3, 4, 5. Let's see how many tick marks we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh, look. Let's count by ones. Okay, this top mark is going to be 16. That might bother some people. If you're okay with that, count by ones. Otherwise, you can count by twos. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So you choose. Ones technically works, or you can count by twos. Let's plot our ordered pairs. I've got 8, 0, so I'm going to go 5, 6, 7, 5, 6, 7, 8, and then I don't go up at all. And then 0 up to 16, which is between 14 and 18. And now I draw my segment. This one looks different. What's different about this one compared to the plumbing one? Here's my plumbing one. This is increasing. This one is decreasing. So that's why we're not able to match smallest x with smallest y like we did before. Because, and this is an important learning point, when I plugged in my smallest, watch the screen, when I plugged in my smallest x, I actually got out the largest. So this was smallest x. I got out my largest y value. And then vice versa. Here, I plugged in my largest y value, and I got out my smallest. So when that switch happens, be careful with using the whole match like we've been doing. Big picture, this is a great reflection of how there's so many different ways of looking at it. If you would rather just say, hey, I don't want to use this whole domain and range piece, and I just want to look at what I calculated and match up the ordered pairs, that works too. Whatever works best for you. Awesome. We are all done with the gas question, and we have one more to look at on page 34, which is saving a bank account. You have been saving for years and have $25,000 in your bank account. Unfortunately, though, you were laid off. Oh no, you were laid off of work and need to withdraw $500 every week to pay for bills. The model, oh, look, I'm given a model, let's highlight it, represents the amount of money in your bank over time. Now this, I don't have an italicized A, but see how it says represents the amount of money? This whole model, which says A equals, represents that. So this is actually A. And it says over time. Time is the other measurable variable. And if I reread, how is money being taken out? Yearly, monthly? Go ahead and reread. See if you can find it. Tells me every week. So this is going to be weeks. So W is number of weeks. A is amount left in account. How many weeks until there's no money left? Ooh, this sounds familiar. Think of the gas question when we were asked how long can they drive until they run out of gas? No gas. Here it's how long till there's no money? Well, no money is a value for weeks or amount left. I'm hoping we're all saying, Ms. J, that's such a silly question. Of course it's amount. And I would agree with you, which means we're saying when does A equal 0? So let's let that happen. 0 equals negative 500 W plus 25,000. And let's solve. I'm solving with you because this is more of an Algebra 1 skill, two-step equation. And I'll pause so you can check out what we have so far. If there's any questions on solving the two steps, please put a little star next to this and show me tomorrow, and we can talk about it. We're going to remember that a negative divided by a negative is a positive, and in your calculators, if you need to pause to go get your calculator, please do so. When we do this division, we get W equals 50, and W is all about weeks, so this is 50 weeks. Domain and range. So domain is all about time, our weeks, so I'm going to put weeks above domain, and range is all about the money. I'm curious, I can't wait to ask you guys tomorrow if anybody kind of connected the dots about how to use all the information we've been given in this one with no math. And I don't mean to say that too soon, but we'll see. So those of you who have an idea of what I just said, check in with me tomorrow. Everybody else, let me get back on the same page with you. We just labeled domain as weeks, range as money. So now I'm going to go look to see, am I given a restriction on weeks or money? Well, if I read this, there's nothing that says like you're going to take out for this many weeks, but I do see that, do you have an infinite amount of money in this account? No, it says you have been saving for a long time and you have this much in the account. That is a restriction on the money. which makes sense. I mean, people would like to have an infinite amount of money in their savings account, but that's not the case. You have a certain amount. In this case, you have the 25,000. So we have a possible value for A, the amount, is between, in a savings account, you're not going to have negative money. So it's between 0 and, $25,000. So this is where a couple seconds ago I said, does anybody realize that after we identify this, we've already done the work? Letting the wheels turn, see what you guys are thinking. Maybe let you think a little more and point out that here, this is another example that we were given a restriction on the range. So at the top, I'm going to write So this is what I mean by you've already done all the work needed. In this follow-up question, it asked you how many weeks until you have no money left in the account. And it was 50. So you can, what this is saying is you can take out up to 50 weeks. So that's going to be 0 to 50. Now the only danger of jumping right to that, which some of us may have seen, is does 0 go with 0 and 50 go with 25,000? If you do the math, which I'm going to show you what that would look like, let's say I didn't see that connection at all. I'm going to plug in my y values. So where I see y in the function, I'll plug in 0 first. So that's 0 equals negative 500w plus 25,000. I'm hoping you'd realize you already did that and you would just say w equals 50, but that's okay. Sometimes we kind of get in the zone and we just do it again. So just in case, I'm going to do it again. Subtract 25,000. Divide to solve for w, both sides by negative 500, and I get w equals 50. If I show my brain the calculation, I see that here's x and here's y. So this gets me the ordered pair 50, comma 0 for my graph. And then when I plug in 25,000, equals negative 500w plus 25,000, and I solve. Again, I'm going to move through this because solving 2 steps is an Algebra 1 skill, but please don't hesitate. If we need help with more solving practice, come see me and we can work on that. Notice these both cancel and I get 0 equals negative 500w. And then again, w is x, you plugged in this for y, so this gets me the ordered pair 0, 25,000. So there are some who will want to see this concrete solving and then get their ordered pairs from that. Others will be okay with saying, okay, well 0 to 50 is my domain values, and say, well, 0, 0 doesn't make sense. Because if you haven't, this is 0 weeks, if you haven't taken any, if you have not withdrawn any money, you still have that much in your account. So these two values match up. And then same thing, for 50 weeks, if you have maxed out your ability to take out money and you have taken out money for a full 50 weeks, you have no money left. So 50 goes over here with 0. Whichever way works with you, I'm trying to present different ways because everyone learns differently, so some might like one way of, better than another. Moral of the story, our two ordered pairs are going to be 50, 0 and 0, 25,000. Working on the graph, our x-axis is going to be number of weeks, and our y-value is going to be amount of money. I see that I'm trying to go from 0 to 50 for the x values. So 10, 20, 30, 40, 50. If I count by tens, I'm already right there. That's a little rough. Maybe if I count by every other line is 10, so really counting by 5. 10, 20, 30, 40. That's a little more spread out, right? Okay. So 0 to 50 for my x values, and I'm trying to get from 0 to 25,000 for my range. Maybe if I count by 5,000. So if this is 5,000, this is 10,000, 15, 20. Man, I'm already at 25,000 and I haven't even passed that point. So I think I picked something too big. Instead of counting by 5,000, maybe 2,000. So 2,000. 4, 6, 8, here's 10,000, 12, 14, 16, 18, and there's 20,000. That's nicer. That's a little more spread out. 22, 24, 26, 28, 30. Nice. We have our scale. Remember, it's an art, not a science. So if you pick something else, go for it. Try it. See if it works. If you're working in pencil, give it a shot. Graphing our ordered pairs. We've got 50, so I go right, 10, 20, 30, 40, 50, 0, meaning I don't go up or down at all. And then 0, 25,000. So 0, here's 20, 22, 24, that's 26, so halfway in between. And we're ready to create our line segment. And we're good. That's it. So at 0 weeks, you still have a full savings account. You're taking out money each week. By the 50th week, you are out of cash. And hopefully you can start putting back money in your savings account because 0 in the savings, no good. All right, folks. These have actually been an example of 1, where you were being given the domain, and 2, where you were given the range. I had intended to have one where it was a real world restriction, meaning you had to think about generally what can you not have, like with time, you can't have negative time, stuff like that. But have no fear, we will at the start of class recap an example in our workbook that was like that. It's actually, if you pull up Google Classroom, it's right here. I'm hoping that, I just pulled up the internet, I'm hoping that this screen is showing up. But in the day 7, the why behind domain restrictions, page 35, and page 32 debrief notes, the page 32 example is the example of you weren't given a restriction, so you have to think about what does the real world say about what you're doing. I'm pretty sure it was the jogger question in our workbook. Happy studying, folks, for tomorrow's quiz. Have a good night, and I will see you all tomorrow.